Imagine taking one single breath and dying instantly. For nearly 1 billion years, that's exactly what would have happened on Earth. No oxygen, no forests, no animals, nothing. Yet today, you're alive because of an almost impossible chain of events. Miss just one of them, and humanity never exists. About 4.5 billion years ago, a planet-sized world named Theia collided with the young Earth. The impact was a cataclysm of cosmic proportions. Theia struck our infant planet at a grazing angle, releasing enough heat to melt Earth's mantle and blasting a massive ring of vaporized rock and dust into orbit. Over a brief period of gravitational consolidation, this hot debris condensed and merged to form the Moon. This violent collision was a necessary foundation for Earth's habitability. The newly formed Moon immediately began exerting a constant gravitational pull on our planet. This orbital interaction stabilized Earth's spin and prevented its axial tilt from wandering chaotically over millions of years. Without the Moon's gravitational grip, Earth's tilt would have drifted wildly, shifting anywhere between 0 and 85 degrees. Such extreme instability would have caused severe global climate swings, making a stable long-term environment impossible. Instead, the Moon locked Earth's tilt into a narrow, reliable range. This steady tilt created predictable seasons, moderated global temperatures, and established the climate stability that would eventually allow complex life to emerge. The birth of the Moon was the first link in the chain of Earth's survival. In the quiet oceans of the primeval Earth, microscopic organisms began altering the planet from the inside out. These were cyanobacteria, simple blue-green microbes that developed a radical method of capturing energy. Using the energy of sunlight, they split water molecules to extract hydrogen, releasing oxygen as a waste product. This process, photosynthesis, filled the waters with free oxygen. But this gas was a hazard to early life. On a planet accustomed to a thick, reducing atmosphere, oxygen was a highly reactive, destructive element. Before any organism could benefit from it, Earth's surface had to absorb this volatile new ingredient, reacting with minerals and oceans in a slow planetary adjustment. A tiny microbe had begun a quiet revolution, initiating a chain reaction that would slowly change the world forever. The oxygen produced by these early microbes did not rise into the atmosphere immediately. Instead, it dissolved into the ancient oceans, encountering a sea rich in dissolved ferrous iron. A colossal chemical reaction began. The oxygen bonded with this iron, turning the oceans into a planet-wide rusting engine. Heavy red sediments of iron oxide precipitated to the sea floor, settling in alternating bands of dark iron and colorful chert. Today, these banded iron formations, preserved in regions like Western Australia's Hamersley Basin, stand as a physical record of Earth's transformation. By 2.4 billion years ago, the dissolved iron was exhausted, and oxygen began escaping into the air. This triggered the Great Oxidation Event, a planetary crisis of unprecedented scale. For the dominant anaerobic microbes of the era, this highly reactive gas was a lethal poison, sparking a global extinction that nearly wiped them out. Yet, this destructive crisis laid the essential foundation for our future. The very gas that decimated early microscopic life would eventually drive the evolution of complex, breathing organisms, turning a toxic waste product into the breath of life. Far beneath the surface, Earth's liquid iron outer core circulates around a solid center. This convective movement of molten metal drives a geodynamo, generating a global magnetic field that envelops the planet. This invisible shield deflects the constant stream of charged particles from the solar wind, preventing it from stripping away our atmosphere and oceans. Mars serves as a stark planetary contrast. When its internal core cooled and its dynamo failed nearly 4 billion years ago, the magnetic shield vanished, allowing the solar wind to slowly erode the Martian atmosphere and leave it dry and barren. Our existence depends on this entire unbroken sequence of planetary events. The collision with Theia formed the Moon to stabilize our climate. Microscopic cyanobacteria produced oxygen, rusting the oceans to form banded iron formations and driving the Great Oxidation Event. Earth's churning molten core generated the magnetic field that kept this air from escaping into space. The next breath you take exists because a chain of near-impossible events aligned. A single misstep, and none of this would be possible. As we search the silent cosmos, we must ask, is life a common spark, or our planet's ultimate, impossible miracle? Share your thoughts below.